Fine guys, thank you everyone for coming. So, few housekeeping notes. So, wherever you are sitting, please do not touch anything which is of property of GalaxEye, because we are trusting you guys that you don't do anything of such kind, and if there is anything of such sort, there will be severe consequences. Second thing, you can connect to the user, the Wi-Fi here. It is user GalaxEye guest and password is GalaxEye pass 123. Once you've done that, other thing that you have to do is just go to GitHub/letstalkspatial and download from the repository August 2024. You can download the drive link. Okay, these three things. So now we can start. So hello everyone, my name is Aman Bagresha. I am one of the organizer of Let's Talk Spatial, and we are hosting this meetup for the 18th time. We have been doing this from past 2 years or so, 2.5 years, and what we have learned so far is that when you meet people, you get to learn a lot from them, and once you make connections, it just becomes much easier for everyone to share knowledge. And what I have realized and what all the organizers have realized is sharing knowledge is gaining knowledge. So with that, what we'll do is, first of all, thanks to GalaxEye, we are hosting here for the second time, and most of you have come here, or many of you have come here for the first time. Maybe you had come for the previous meetup which happened I think a year ago at GalaxEye on the first floor, and now we are growing. Now disclaimer, I work at GalaxEye as geospatial scientist, and I'm thankful for them to again host us for this meetup. So before we begin, and I'll talk about Let's Talk Spatial also, I would request Rakshit to just speak about GalaxEye and like what we are currently doing. So please, Rakshit. So maybe I can introduce Rakshit. So he's one of the founding members and currently the VP of product. So
hi everyone, good morning first of all, and thanks a lot that you guys were able to show up on a Saturday morning, and also grateful that Aman, you took the initiative to organize this workshop. A little bit about GalaxEye. We are a space tech company. We focus on building the infrastructure to get the best quality Earth observation data from space, right? And in order to do that, we are also building our own satellites. We are building our own sensors, synthetic aperture radar, multispectral sensors, which we will be putting into orbit by next year. Little bit about workshops. So internally, we also build a lot of software products and tools on top of geospatial data for our customers. And in the last 1 year, we have figured out the immense value that QGIS as a tool has added to our organization, right? Be it labeling of data, be it doing a lot of ad hoc analysis. It's just extremely useful, and I personally think that having the knowledge of this tool definitely gives you an edge when it comes to working with geospatial data, and especially in this particular industry.
Thank you so much, Rakshit. What we'll do now is I'll ask you guys to do few things. Okay, the website is down, no worries. You can join the Slack group. Oh, sorry, yes. So, if you want to, so we have almost all of our workshops or talks are streamed online when we do it in person, and you can find those on the YouTube channel. If you go to the YouTube channel Let's Talk Spatial, you can find all the streams that have happened previously. So these are the streams, and few are recorded and then put online. So you can watch. And what is interesting is most of the space tech startups or companies which are in geospatial are mostly located in Bangalore. So it is actually a good thing for us that we get to meet so many folks, and there is one concentration of geospatial knowledge that is happening in Bangalore, which is a good thing, and that is why we are trying to move around different places in Bangalore and explore what different companies are trying to do and what people are actually trying to do there. So this is one place where you can go. Other is, if you go to the contacts page on the website, you will have a Let's Talk Spatial Slack, and when you click, you can actually go to, you will be invited for this Slack channel where we not just share about the meetup, but also some news articles or some development in geospatial or some projects that people have done. So you can come to this channel, and also internship and job opportunities if you are looking for that. So there are all these places where you can go to, where we put different things. So that is again a place where you can look out for. And with that, what we'll do is we'll start with the workshop. So the idea for this workshop is, I hope everyone has downloaded the data set, but if you haven't, don't worry, you can just follow along. What we'll do in this workshop, the idea is, the end goal is to label satellite imagery. So before we do that, I just want to know what is your familiarity with QGIS. If you are a beginner, just put your hands up so that I get an understanding. Alright, and if you are intermediary or pro level, so maybe you can just raise your hand up. If you know, like, you're working for more than a year, even then that is fine with me. Alright, so a lot of people are beginner, so I'll assume what I'll do is I'll go step by step in the initial steps, and then we can take it forward and see what, if you face any problem, there are people around. So there is Yuvraj who will assist in this, you will assist you guys if you face any trouble, and there is Thiako who is also a co-organizer, will help you if there is any problem while you do hands-on workshop. Alright, so little about me. I along with 3 other people. So if you go to the website, you will find all the organizers here. So there are 4 organizers, and so I currently work at geospatial scientist at GalaxEye, and I also have YouTube and blog, which you can find from that link. And I am a member, I am representing IEEE GRSS. I am the head of young professional. So if you guys, so what interesting is, Let's Talk Spatial is now sponsored by IEEE GRSS. So now whichever event we do, we are thankful for IEEE GRSS as well, which helps us with the snacks, with teas. So these things are, we are grateful to IEEE GRSS. And benefit of IEEE GRSS is that once you join the membership program, you get to access a lot of different materials and get to connect with communities from industry and academia. So I am from industry, there are a lot of people from academia as well. So you get a mix of both, and there are highly qualified professionals there. So for if you are students, it is very cheap or very economical for you to subscribe or become a member. It might be a little costly for you if you are an industry member. So yeah, do check out or connect with me afterwards for if you want to become a member of IEEE GRSS. Alright, so we'll start with GIS. I want to know how many of you are students. So maybe you can raise students, as in I count in PhD students as well. So PhD, masters or degree or undergrad or whatever. Alright, so nearly half of them are students. So, and okay, what course are you currently in? So are you in GIS core, or are you in civil engineering, or so maybe if you are specializing in GIS, maybe you can raise your hand, or geoinformatics, or okay. And what about you guys? Are you like from electronics and communication? Oh, great. Fine then. So what I'll do is I'll take examples of different not just one domain but multiple domains so that everyone can understand. So what we are trying to do here is in GIS it is just capture, represent, process. So you have a data set and you want to say process the image or do image processing, do signal processing, and then analyze the image and then visualize the image. So these are the kind of stuff that you could do in a GIS software. So geographic information here is could be understood as you have so much collection of data, you're trying to bring together all of that and then process it in a way that it becomes an information. Now many of you might have been using ArcGIS, so maybe you can raise your hand who have been using ArcGIS and or are still using ArcGIS. Okay, few hands. If I were to do this 3 years ago, half of the crowd would have chosen ArcGIS. So what has happened in recent past is QGIS has taken over ArcGIS, in my opinion, and it has become the number one GIS software because it is quite easy to use and it is free of cost. Now what we are going to do in this is few basic steps that everyone across the board has to know is adding base map, plugins, styling and digitization. These are the 4 essential things that you will have to learn no matter which domain are you in. If you are in electronics, civil or say geoinformatics, you have to know about this. So let us quickly begin. There are a lot of things to cover and this is again recorded, so you can go back and watch it. But if you have to do hands-on so that you learn here. Otherwise there is no point like coming to hands-on session and not doing the stuff yourself. So there are people to help you out. Now hopefully everyone has installed QGIS, and which version of QGIS are you currently using? Can you just let me know? There has been a lot of changes in the previous QGIS versions. If you are using the latest 3.34, that is the best currently, so you must be using that. Otherwise some features which might be demonstrating today might not be present in previous versions. So make sure that you are using 3.38 or 3.34. Sorry, which version is it? 3.28. You can go to if you want to check out which version it is, go to the help and click on check QGIS version. So like currently I am using 3.38, that is the latest version. 3.34, good enough, yes. 3.34 is good enough. So make sure you are using 3.34, even 3.28 is fine. It's not that it does not break or does not crash, so I can say that. 3.38, 3.28 is fine. So what will, some of the features are new which I'll show that 3.38 only has, but other features once you upgrade or it becomes long-term release, you'll get access to those features as well. So initially now let's start with hands-on. Let's open QGIS and then I'll try to first show you how do you add base maps. That is the first thing that you have to do. When you open QGIS, you don't see anything. A lot of people might already have that setup, and some of you don't have. What we'll do is we'll go to the browser tab. If you don't find the browser tab, you can right click on the top pane, and here you should see browser panel. That should be selected for you. If not, unselect and again select it, and you should get an access to this browser pane. Now this is the first step. What you have to do here is add URLs to your base maps. So there are multiple base maps that we'll be adding. So I have currently a lot of these. We'll add few of them. Now to add any base map, XYZ tiles, inside XYZ tiles you just right click and then say new connection, and it will give you hope you are able to see. So what you need to enter here is the details of which base map do you want to add, and for that we can go to let's search online, add XYZ base map in QGIS. And once you are on this page, maybe you can click on this link. This is trustworthy, so you can click on mapscaping.com/basemaps, adding base map in QGIS. I'll zoom in a little bit. Okay, so there are multiple base maps that you can add. All of these are free to use within QGIS, but if you are trying to do some kind of commercial application on top of it, it is prohibited. It is illegal to do that. So you can't just download chips of say satellite imagery and then do any kind of analysis. Now what we'll add is Google base map. Most of the layers in or the satellite imagery is updated in Google base map. What we'll do is we'll select the URL, just copy the URL from this website, and if at any point you feel it is very fast, please let me know, we can do it again. So copy this URL and paste it in the URL section. So paste it in the URL section and type Google Maps satellite imagery. So these are the two things you have to do, that's it. In the XYZ tile, you have to open a new connection, add the URL and the name of the satellite satellite base map. So here in this case it is Google Map satellites. Then you can click on OK. Let's click on OK, and then so once you click on OK, you will have your satellite imagery layer here, XYZ tile here. In my case it is Google Map satellite imagery and I can see it. You can just double click on it and the satellite imagery will load. Okay, hope everyone is able to load the satellite imagery. Now similarly, you can also load other base maps that you would wish to. There is Bing Maps, there is also Esri World Imagery, and there is Open Topo Map, Maps in Global Terrain. So there are multiple base maps that you can try to load, and each of them is useful. So maybe I can load from the Stadia maps that I have taken from. So this is just a black and white and just very cool to look at, and this layer only contains the water bodies in and around Bangalore, and the layers are just two colors, black and white. So very beautiful, very artistic looking Stadia maps Stamen toner. If you want to look at the global terrain, you can also have maps in global terrain. So if you look at, so these are kind of base maps that you can add to. Now I'll give you 2 minutes, maybe select your choice of base map that you would like to. Don't select again satellite imagery, but from the same website, select any other base map that you would like to add, and just select the URL. Again add a new connection to XYZ layer, and then load it onto your screen. if you are not able to load satellite imagery, it might be that Google Maps API is like it's failing. So for time being, don't use that, and it will work on your network, on your personal say home network. But here, because multiple people are trying to access the same space map on the same IP address, it might be failing. What you could do is you could select Bing Maps satellite imagery and have that connection. Alright, hope everyone is able to access at least one base map. One satellite imagery base map. You need to have one satellite imagery base map, which will be helpful for us when you go in the last step when you try to label imagery. But otherwise, if you're not able to access, you can take OpenStreetMap data as one of the tile layer and then add that. Even that will work fine. So OpenStreetMap, if you search so hopefully here OpenStreet. So here it is. So you'll find OpenStreetMap tiles also on the same website. You can use that if you are not able to get satellite imagery base map. Okay, so now we'll look at few tools to move around and navigate. And a lot of times I've seen is people are stuck on their mouse itself. So maybe we'll develop a habit to for shortcuts. That is one thing. In this exercise, you have to learn how to use shortcuts and rely less on mouse. And the second is how do you use the toolbar on the bottom left. So if you see here, type to locate. So there's a a search bar on the bottom left, and we will use this extensively for anything that we want to do. Instead of moving your mouse to that place, we'll actually just press Ctrl K and then try to search all the things that we require. So the way I do it is, say you have this QGIS layer, QGIS panel open, and I press Ctrl K, and that takes me to this type to locate pane on the bottom left, search pane. And from here I do all my operations. So this can help you navigate to different places, can open processing toolbars, can also do geocoding. So there are a lot of things it can do. So all the options are there listed here. What are the potential of this search bar? So the first thing that we'll do is we'll go to Bangalore or maybe any place that you want to. You can just search for that. The way you do it is press the forward arrow, what is it called? Greater than sign. Just press that or enter that and then press space. Press the greater than sign and then press and then enter space. Then enter the place that you want to go to. So here I'll enter Bangalore. So this should load two options. It is similar to doing a Google search on maps, but behind the scene it is using nominatim. So the way you should do it is enter / and then space and then your place of search. So a lot of times, say if you are searching for place which is very local or very, say if you are trying to search this building, GalaxEye space, it won't pop up here because it is using nominatim behind the scene, and that has limitation as to what it can search and what it cannot. Maybe I can try giving a entry of GalaxEye. Oh, it is there. So someone has actually mapped GalaxEye space on OpenStreetMap. That is why it is popping up. That is good to know. So here it is. So it is also exactly located where the location is. So again, what we want to do is not use mouse and only try to do with keyboard. That is a good habit to follow. Just press Ctrl K and then search this option. Maybe I can increase the font. Okay, so just give me a minute. I'll close this and then restart because I want to increase the font size. Another thing that maybe you can, so a lot of you are installing QGIS via the, how many of you are using Windows system? So almost all of them are using Windows. So what a new shift from what you usually do is you can install Conda environment, and within that if you install a similar package like Python, you can also install QGIS, and then within that Conda environment you have multiple versions of QGIS. Even that is possible. So what I've done in my system is I have a QGIS Conda environment, and within that I've installed QGIS. So the procedure that I follow usually is, in any system I install a new Conda environment, and if I want to play around with multiple, oh yeah, if you know Conda, are you familiar with Conda? How many of you are not? Okay, majority knows, so that is a good thing. So in Windows, so the problem with installing geospatial packages is you can't do it with pip. If you are on Windows, you can't do it with pip. There's always some kind of problem that you face. So Conda is the approach that you have to follow. So those who don't know Conda, it's an alternative to pip, where you can, it's again a package manager where you install a lot of packages inside that, and it takes care of all the conflicts and it helps you resolve. On Windows system especially, it is very useful. So if you have Conda, you can install QGIS within that and load any version of QGIS that you want to specify, not necessarily that you want the latest or LTR version. The way I do it is QGIS, and then I just press enter and it loads the QGIS. A lot of you might not have 3.38 because this was updated only on Conda, and also it is available on all the repositories, but that is the way I do it. So I'll just load another map again, and now I'll type in, I'll do the same procedure, but before that I want to show you what are the different things that you can do with this search bar. We've already looked at the greater than sign nominatim geocoder, but we'll also look at some other tool set that will later will be very useful for us to go ahead with. As of now, I'll again type GalaxEye space, So yeah, so it takes you to that location. So that is first thing that you have to know. Other thing is you have to know about spatial bookmarks. Again, this is very useful. These are few things that once you get accustomed to, it becomes very easy for you to then navigate, and just in back of your mind it is always there that I have this kind of thing available. So now suppose you visit some location very often for your project, you always have to find, say I was doing a study on KRS dam, and I always have to search because it is quite large and I know which place it is, I can directly go there. But if suppose you are going to some remote area and then you don't know which exact area I was looking for on QGIS, once you identify that region, you can bookmark that spatial extent, and the next time you come there, you don't have to search and just directly navigate to that region. So this is how it is very useful. In my case, what I'll do is I want to bookmark this region, whichever I've loaded, so that because I frequent here quite often, I just bookmark this. I go to the top pane. So there's an option called as new spatial bookmark. Again, try to learn the shortcuts. Don't try to, if you are new, you can move around with mouse, but if you are intermediary or pro, but don't try to use your mouse. So we'll click on Control B and this will pop up a new bookmark pane. Here you can type in what this place means to you. So maybe I can say GalaxEye space office, and then keep everything as is. I don't want to change anything here, and then click on save. So that is all you have to do. So once you, hope everyone is with me till here, you know how to create spatial bookmarks. Now if I go to some other place, say I go to some other random place, and now I want to again move back to that location, what I can do is, on the top pane itself, just beside your bookmarks, just a minute. When you've created new spatial bookmarks, just beside that you also have show spatial bookmarks, and just note down the shortcut Ctrl+Shift+B, and this will bring you to your browser pane. Again, if you guys are stuck anywhere, please let us know. Also, if you don't have the browser pane, now you know where to look out for. Just click on the top pane and right click and click on browser pane. And now double click on the location that you have saved, any bookmark that you have saved, and you will be redirected with the spatial extent that you have saved. So again, this is like very useful technique, and a lot of people have struggled to again move to the same location that they were previously visiting. You can create a project, and then each time you visit a new location, you can save it. If you don't want to, search it again. Alright, everyone is with me, right? So next. Okay, so there are a few other things that we'll look at. Now we'll look at the scale, magnifier and renderer. Give me just a moment. If anybody needs any help, please raise your hand and we'll be happy to assist. This workshop is mainly meant for helping out folks who are new, so please don't hesitate to raise your hand and ask for help. Alright, so
the spatial bookmark is the geo-bounding, or is it
the bounding box, the view.
view? So if I say zoom in, and then take the spatial mark and zoom out and take the spatial. No? Both are
Yes, both are different. Both are different. Okay, great question, thanks. Now what we'll do is look at few bottom panes which are coordinate, scale, magnifier, rotation and render. So these are things that we look at. First, let us start from the right. So here you see EPSG 3857 and a lot of you, how many of you are familiar with the coordinate reference system? Just raise your hand. Coordinate reference system. Okay, so only like less than half are familiar with coordinate reference system. What we'll do is we'll not have the headache of doing multiple or explaining coordinate reference system. It's a topic in itself. But what we want to do is explain what this 3857 means. You will find a lot of different reference system. Now we mainly work in so Google Maps has the same coordinate reference system. It is the way you project the data or project your map. Here you're seeing in Earth is 3D object or it is a sphere, similar to sphere or ellipsoid. So you can't project your entire Earth on a plain flat surface. That is why you have to project your spherical Earth onto a flat surface. That is why you do a certain kind of projections. Say you just open the Earth and just flatten it out, and that is what we are seeing it here. Maybe there is some kind of distortion. So all these kind of errors might occur when you try to project your data from say a sphere to a flat surface. And for our purpose, we are not going to deal with anything other than 3857. There might be another coordinate reference system 4326 which we might encounter later, which is a geographic coordinate reference system which defines our Earth in a spatial coordinate, in a spherical manner. So that means it has it has latitude and longitude. Currently what you see is not latitude, longitude, it is in some different projections. So if I were to explain this, I can first show you these coordinates. So on the bottom what you see is a big number, comma a big number. So there are two x comma y numbers that you see. These are in projected coordinate reference system, and this represents an Earth in certain fashion. If I were to change my EPSG to 4326, if I just search for that, you don't have to do that right now, then your coordinates changes and it changes to latitude, longitude. This coordinate can be put on the Google Maps and it will take you to the location that you wish for. Now what is the difference? Let us look at the difference. So if you see, when I changed my EPSG to 4326, it is a rectangular box. Correct, the entire map is a rectangular box. Now if I change that to say 3857, which is a Mercator projection, it changes to a square. So it changes to a square. That is the difference, that each projection has some kind of irregularity or error inbuilt with it. And if you are doing any project or any analysis, make sure you are in projected coordinate system, and that projected coordinate system is accurate to the location that you currently are. Suppose we are in Bangalore, and a lot of times if we were to use any projected coordinate system, it would either be UTM zones for this location. We are not going to deal with that, but try not to use a geographic coordinate system if you are dealing with anything specific region wise. So it's better to use projected coordinate system. Again, that is a different topic. We are not going to, because there is a lot of various disciplines of audience here. What we want to do is look at this scale. Scale is what is 1 unit of an actual pixel on ground to compared on the map. That is what it is trying to see, and I'll try to change this to 1:1. So that means 1 pixel on ground. So whatever is a 1 unit on ground is 1 unit on the base map. Now if I increase the scale, say to 1000, still does not. Oh, I'm at some wrong locations. Anyway, so what it does is, so if you increase, so what does the scale mean here? 1 is to a big number here. It means the value that you're seeing on map, or the 1 unit on map. So if you just move 1 unit on map, it means 3476231 units on the actual ground. So that is what it's trying to say. And you can fix the scale once. You can click on this, lock the scale. So now you can't zoom out. Try to do this. Just lock the scale. Why is it? Yeah, so what is happening is, once you lock the scale, it only magnifies. So you have that at that zoom level, the image is loaded or the base map is loaded. Now when you try to zoom in, it only magnifies. It does not show you more pixels for that location. That is what is happening. So you can turn off the lock again. And another thing that we will see is this render option. Just uncheck the render option and then try to navigate again. Uncheck the render option and then move around. What you will see is, it does not load anything that is outside your bounding box or your extent. So in this case, I only have this map loaded. I cannot see anything beyond this. Now if I turn on the render again, I can see the entire world. So say I move into a specific location and turn off the render. Now it cannot load or cannot generate or cannot send request to any other tile to the server or to the base map that you are requesting for. What it has already loaded, it just loads it and it does not now ask for any other new tiles because we have turned out rendering. So if this is again very useful if you have very huge data and you don't want to, for each time you are moving around, and we'll see an example, each time you are moving around, you are asking for, say, the data to again load to that extent. And nowadays that is a huge, it is a problem because suppose you want to load TBs of data, which you can easily nowadays because you have cloud native formats, you can just directly ask a URL from the provider and then paste it here and the entire data is loaded, which we'll see in some while. Once you do that, each time you move around, a new data is being asked for from the provider, and that puts a load on your bandwidth as well and also on QGIS. So to avoid that, what we do is we turn off the rendering mode and only select the region that we want to explore, and just outside of it we do not care. So that is a very useful option that you generally use. Alright, so these are the navigation tools, and we have looked at location bar already. We have added base map. So now is the time to use the data set that we have. So what we'll do is, first let us explore vector and rasters, and then we can go ahead with actually loading the data. Now, so again, vectors, most of you might know what vectors are, what rasters are. For those who don't know, vectors are point, line, polygon. So the road that you see has been drawn on some map, and which is a line. The building is a polygon. Point is some kind of point of interest. Say GalaxEye space is a point because the building has some kind of structure, but the entity itself, that is a point. So that is located using a point. Some other example of point can be your say a dustbin. you cannot exactly draw the shape of the dustbin. Say you want to locate all the dustbins in Bangalore or wherever there are street lamps. So the way you do it is just have a point for every location that you go to. So that is features of line, points, polygons. Rasters are continuous data. So the image that you see here is continuous. So this is a raster itself. And rasters can be thought of as an image. It is an image itself. So it is always a grid. You cannot see anything which is not rectangular. Rasters will always be rectangular. Now to just show you how does a data look at, how many of you are familiar with or have any programming knowledge as such? Any programming language? Okay, very few. So what is happening is, so this raster is just a grid of numbers, and each numbers, when you align them together, forms a raster, and when you display it, it just is appealing to or gives you some kind of information. So here on the left you are seeing a raster, and when you see zoom into one pixel, you have multiple values in that specific cell. So and each cell is of certain size. Say an image, when you see a 23 megapixel camera, that means that it has so many pixels within that entire image. So that is what it is trying to convey. And we'll look at few. Now when a satellite captures data from an image is captured from satellite, each pixel has some kind of dimension to it. Now typically, now people have even broke that barrier. You can go up to, from satellite itself, you can go sub 10 meters, 10 centimeters of pixel level. So each pixel in an image can be of 10 centimeters. What we'll look at in this workshop is of 10 meters pixel. Each pixel is of 10 meters, and we'll try to explore that later in this workshop. So what you have to understand is there are two types, vectors and rasters. And rasters are always continuous and it is always rectangular. Vectors are these geometries, point, polygons and lines. So with this, what we'll do is we'll look at the actual data. We'll look at two data set. One is India boundary and also is digital elevation model, which is the elevation data of Bangalore. Now to download this data, you can either click on this link, or you might already have downloaded the data set that I provided from the drive link. We'll use the latter option, which is, so when you download the file from the drive, you'll have So once you have downloaded this file, you have this QGIS for Dummies file, which is .jpkg format. What we'll do is, we'll just drag and drop that to QGIS. So everyone drag and drop the entire JPKG file to QGIS.
So can we get the link?
Sure. So if you want the link, you can just go to letstalkspatial and August 2024 and then download the drive link from the drive link. Okay, so before we move ahead, I want to take a moment to explain few formats of rasters and vectors. So your typical image from photographs are say PNG or JPEG, and in GIS world or geospatial world, typically what we use is TIFFs or TIFF. So these are the formats that we generally use. There are multiple different formats of raster data. Similarly, there are multiple different formats of vector data. Most of you might have heard of GeoJSON or JSON format. GeoJSON is the geospatial version of JSON. So it embeds your geometry as well within it. So that is one format. Another format of vector data is shapefiles. Many of you might, if you have worked, shapefile is bunch of files that you have, and when you club together all of them, you try to load. So that is one entire file. We'll see at that file as well. And there is one format called as JPKG, which is geo format, geo package. This is a database itself. This is again a fairly new format introduced in QGIS. Again, it can now store vectors and rasters also. So that is why you see here, once you've loaded JPKG, which is a format specifically built for vectors, but now it's a database, so you can now store vectors and rasters also. You have multiple different files within it. From these files, we'll only load one file. So within this, you can also store PDFs. You can also store any kind of stuff, because this is just a database. Now, what we are trying to load is this QGIS project. If you have gone ahead and just clicked on open, it will load all the files and additional files as well. Don't do that, just click on QGIS project and then click on open. So a lot of you might not be able to, if you are facing any problem like dragging and dropping to the file, what you could do is, because GeoPackage is a database, you could come here and then on the browser pane there is a tab called as GeoPackage, and it works similar to other things that you might have do, but here what you have to do is just right click, similar to what you have done for adding base maps. You can right click and say add new connection and go navigate to the folder where you have your downloaded file and then click on JPKG, QGIS for dummy.jpkg, and then click on OK. Now because I've already added that, maybe I'll try to remove it first and then add it, so that every one of us are. So I right click, add, navigate to the folder and then add QGIS for dummies.jpkg. So once I've added that, you can expand this. You'll find all the layers that I have put inside this file or inside this database. Now from here we just want to double click on QGIS project. Once you double click, it will load all the layers that we want to show or display. So why I want to emphasize here is a lot of people are working with shapefiles even today, or even GeoPackage even today. With GeoJSON even today. So now I think it is 2024 and we have to move away from shapefiles. So please try not to, with anyone, even in your office or any place, please try to avoid shapefiles. Once user community tries to avoid shapefiles, even the developers or the distributors or any platform will also not use these as one of the options. It is again a very archaic project that, and it has multiple files. If I show you shapefile, and where is, so I'll try to show you a shapefile and then maybe you can ask yourself as to if this is a good so this is a shapefile. So you have set of 5 to 6 files. I just opened it for your display, that this is another format that you can load your data into. But again, you have 6 files. You have, whenever you are sharing your data, you have to have all these files within a single folder, or you have to share an entire folder. You can't share just one file. So please try to not use shapefiles here onwards. Now what we want to do in this project is couple of things. We want to explore vectors, we want to explore rasters and the tools associated with it. Now here is where the magic starts of QGIS. Till now we have just explored the basics. Now we'll dive deep into each of these concepts. So far everyone should be able to load your project. Now what we want to do is, let me explain what is there on this screen first, then we'll go dive deep into explaining each or playing around with each of the files. So I've loaded first the country boundary. Now again, an interest or important point is always go to the trusted source to download your country boundary. Many of the places where you see is your Jammu and Kashmir or Pakistan, POK is not present on your boundary. So the best way to find your boundaries are Survey of India, and you have to log into their portal and you can download the boundaries file from there. And even if you want some state boundaries, you can go to the state, say KSR SAC or Madhya Pradesh remote sensing department. Go to their official website, only download from there. Never ever download from any other, say from a foreign source. They might not include or they might not have the recent boundaries, or might include conflicted regions in their area and not in our region. So always use that boundaries. So this boundary that you are seeing in the base map, one second. I think I corrupted. Oh, I deleted that as well, so sorry. Okay. First thing that we see is polymap 15-meter area. So this is a vector geometry. This is, and if you can turn on and off from this checkbox. That is the first thing you have to know. And the base map that you are seeing is OpenStreetMap. You can look for OpenStreetMap online as well. OpenStreet. And again, it is similar to Google Maps, but this is user contributed. Everyone from around the world contributes, and this is free to use. You can use it whichever way you want to. And even navigation apps nowadays, say Ola Maps or even Apple Maps, use these as their one of their data source. So you can trust the data that is there here. There are some faults as is with any other data source, but you can trust the data source here. So the base map is that, what you see on the base map. Then there is one geometry which is a polygon. This entire region is polygon, which is India boundary, and you have multiple layers. And on the top three are the images, which are Sentinel-2 images, and rasters is, this is the digital elevation model. Let me rename it. If you turn on the toggle and turn on and off, you'll find that this is a digital elevation model which tells the elevation of every point on that location. And again, this data is derived from the satellites. We'll look into each of them. So the first thing that we do is explore vectors. So we can turn off all the layers except the vectors. And there are few things that we do here. Each time when you zoom in and you want to come or zoom out, you right click on that region and then click on zoom to layers. You can right click and say zoom to layers. That will give you the entire extent of that polygon. You can also show feature count, which will give you how many features are there in. So you might think India has one single feature, but that is not the case here. There are 314 pieces of polygons which have been attached and created a one layer. So now what these are the layers. So maybe if I can right click, and there is one important thing that we'll learn here is attribute tables. So attribute tables tells you the information associated with each of the geometry. So this geometry in behind has some kind of information associated with it. If you click on, let us not go this way. First what we'll do is, go to the top pane and then select feature by area or select click. Just select this option and select India region. What you would see is each of the polygons is a single polygon in itself. So you can click on any of the features. By this, what I am trying to do is select that region, select the entire boundary. If you want to navigate around, you can click on pan map and then navigate around the region. And if you want to zoom in, just with your two hand finger you can just go press down and you'll go in or zoom in. What we are trying to see is we want to select features here, or we want to select the entire region. So what you can do if you want to do the entire region is say left click and then drag, and this will help you select all the features. You can also select by polygon. Say if you draw a polygon like this, so all the intersecting features with this polygon will be selected. Say I do this. Now I've unselected all of these. I do it again. I click on select features by polygon. I just want to select these features. I want to exclude Andaman Nicobar for now, and I've selected these features. Now just beside the selection option, you will also find deselect features from current layer. You can click on deselect, Control Shift A, or you can just click on this. All the features which are selected can be deselected. Alright, so what we've done is we have selected, say, the mainland India. So once we have selected this, you can right click on that layer, go to open attribute table. So attribute table can be thought of as data associated with the geometry. Now there are multiple things here, and this information is not useful to us. I just want to see the feature which is selected. I click on the bottom pane, show all features, and click on show selected features. So the selected feature, which is this in the background, has some kind of information associated with it. It has an FID of 314, ID, and line width. These currently do not make sense, but what I want to convey is, say you are some region, somewhere, some place that you don't know which area was selected. You can come here and then click on this row and then go to or zoom into the selected rows. It will take you back to the region which is selected. We'll come to the top and then click on select features. We'll again select few features in the bottom pane, and now my ultimate aim now is to calculate what is the total area of India. Now to do that, I cannot just, the first thing that I had thought was maybe I can select this region, say select India, and then calculate the total area of India. Now if I want to calculate total area, I have to also include the east and west islands of the Indian subcontinent. So entire region I select, I click and drag and then select it. Once this is selected, I know that all my polygons have been selected. Now to calculate area, I can come to the top and click on open field calculator. This opens up a dialog box which will help you do multiple things. Here we'll try to find out the area. Now to calculate area, the command is $area. So $area will give you the area of single feature. But we want to calculate area of the entire India, so that is why we sum up all the areas. You just do sum and $area, which will help you identify the total area of India. Now this is in meter square. We'll come to the top and again deselect the features which are selected. We'll first try to look at what is, say I just want to know the area of the mainland India. I don't want to know what these areas are. Maybe they are quite smaller compared to the mainland India. So if I just want to know the area of this region, say mainland India, what I have to do is, there's a feature called as identity features on the top, and you can click on identity features and click the region that you want to know the area of. Say I want to know the area of mainland India, I click on that, and on the left pane you have multiple information related to this feature or this specific polygon itself. And here you would see areas of this mainland India. Now there are two areas here, one is Cartesian and one is ellipsoidal. If you want accurate area, always look at ellipsoidal. So this is the total area of India. Now this is in meter square. Now if you want to convert it, you can right click on this, copy feature attributes or copy attribute value, and if I open in text editor, this copies the value for me. I just come here and then say convert meter square to kilometer square. So total area is 325 kilometer square is the total area which we say, and let's check online what is the India kilometer square. So again it's roughly the same, that is what we were expecting, and that is the result. As you can see, we are very close by, so the value that we are getting from QGIS is quite accurate. So I want to highlight here the difference between these two, but before that everyone should be on the same page that you click on this identity tool on top, click on any feature that you want to highlight or want to know the more information about. You can click on that, and on the pane you have all the information related to that feature. You have the area, you have the perimeter as well, and the associated attribute with it. So on the bottom you see the attributes for these features. For now what I wanted was the total area of this polygon. So I clicked on area and I looked at area, ellipsoidal and Cartesian. So there are two things here which you want to know is Cartesian is the projected area, which might be very off if it is for large regions. Say for the entire India, because you have converted your spherical object to a planar object or a projected object, there are a lot of distortions, and that is why the area that you get from Cartesian is way off than area that you get from ellipsoidal. Here itself you can see there is a difference of, I don't know, so if you see in kilometers it's about 1 lakh. So there is a difference of 1 lakh square kilometers. So that's a huge difference when you compare Cartesian and ellipsoidal. So always when you want to do any kind of analysis on a large region, always use ellipsoidal as your area. Do not use even if it is say from Karnataka to Andhra Pradesh, you want to calculate the distance, which might say here from Tumkur. Here the distance itself, the area itself might change drastically because your earth is curvature, you're not taking into account the curvature of the earth. So it's very important that you, whenever you're calculating area across a large region, always make sure it is ellipsoidal and not Cartesian. So now you know how to calculate the area for any polygon. There are two ways that I've told you. One is the identity feature, which is very easy, but it only works for single polygon. You can left click and then drag for the entire region, and on the left pane you will have information about every feature, and this is like laborious to go through. So you have area for every polygon in that India has. Say neighboring regions, there are multiple polygons here. There are multiple polygons here, and each of these has some kind of area. And if you want to calculate the total area of India, the best way, the easiest way is to come to this field calculator, which I told you before, and calculate the area, just summing up areas of individual polygons. So this is the method that you use. Let me zoom. Can't zoom in, so I'll paste it in text editor. If you I can't even zoom here. Yeah, but the command is sum of dollar area. Hope you are like familiar now with what dollar area tells you. Dollar area tells you area of just every single feature. But if you want to calculate the sum of all features, you do a sum over that. You can also do max. So all the operations that you typically do with geometries, you can now do here. Say max area from all the features. Now we get that. You can also do minimum of all areas. You can also do that. So this is a gist of, we'll again dive deep into later. We have little time left. So what we'll now do is, once we've done with the polygon, now we know how to calculate area of polygons. So any polygon you don't want to work with, there are two key features of QGIS. One is the identify features, and just beside that you have open field calculator. You use these two simultaneously or whichever is required according to your requirements. Alright, so once this is done, now we come to rasters. Just click on the raster and zoom to the layer. Unselect all of the other options and now only select rasters. Now this is the raster of Bangalore. And now what you see on the image, first look at the image and then see what it is trying to convey. You see dark regions here and lighter regions here. So darker regions mean, so this is a digital elevation model. Let me first tell you what this is. Digital elevation model is your elevations. So what we have done is we have taken satellite imagery and tried to model the elevation that is actually on the earth. Say Bangalore is at say 900 meters. And now every region now keeps changing. The elevation keeps changing in Bangalore. Even if you go on this road, if you drive down 1 kilometer, the elevation might be 10 meters different from what it is here. So you want to model all of these so that you can plan accordingly. Say city planning is very important. When if you want to do drainage design, you have to plan your stream networks or your sewage drains only at low lying areas. You can't plan it at high elevation areas. So this is where all digital elevation model might help. It is also help for army. So they also need very high accurate digital elevation model, because you know where there are very steep terrains or where there is high flat ground, so you can plan accordingly. Now what we'll try to do is, we'll again go to our spatial bookmark that I had planned, that I had bookmarked. I'll go to that bookmark. So currently I don't have, so actually I reopened and I did not save the project. Okay, so now what I want to do is, I want to calculate the difference between elevation, or I want to see the trend line as to how elevation is changing on this road. That is what I want to do, and for that I have my base map loaded, which is QGIS. Please turn on your QGIS layer, and I want to see the elevation difference between this point on the bottom and where the road ends, where it connects this layer. Now if I want to calculate the elevation difference, I have my elevation model which tells me how elevation is changing. I'll do few things here. One is, I'll go to the layer styling panel. Before we calculate the difference in elevation between 2 points, we'll go to layer styling panel, and if you don't see layer styling panel, on the top left of your layers you'll find open the layer styling panel, which is a shortcut of F7. You can click on that. So you can click on the layer styling panel, and here we want to do few things. We come to min max value setting, and again this is very useful. This works for any image, not just for digital elevation model. So image processing folks, electronics folks, this might be of help to you. What we are doing here is, we want to see the so in this image there's a lot of differences that you see. If you zoom out in the entire image, you can see a lot of differences, because there are levels from 0 to 255. If you assume that as the scale, you can see the difference. But if you zoom into any specific location, you hardly see any difference here. There even might be a lot of difference. So what we want to do now is calculate the change the statistic extent to updated canvas. You should go to the layer styling panel and calculate statistic extent, and then update the canvas. So what it is doing here is, it is just looking at your current extent and calculating min max of that current extent, then plotting your entire image. Now if you zoom out with that same setting, you will see that this layer min max value is changing. If you closely notice on the color gradient min and max value, if you can see that as I zoom in, my values are changing, min and max value are changing. What it is doing is, each time I zoom in, it takes that extent and calculates the min and max value. So I now know that the region that I am looking at has a max value of 855 meters. So that is the height, maximum height in my region. And if I zoom out, for this entire region, my maximum height is 1032. So that is one setting that you should always not always turn on. Whenever you are working with small layers, you can turn these on, because it takes computation power to each time compute. Whenever you zoom in, you have to compute it, recompute again. So always make sure to keep updated canvas for statistic extent. If you're trying to explore the image, then that is one good option. Another option which a lot of image processing folks might be looking at is mean plus standard deviation. So not always. So whenever you're doing machine learning or deep learning, you do some kind of pre-processing to your image, and those you don't know what pre-processing to use. For those use cases, a very important step is to first look at yourself. If you are able to see through your eyes some kind of features, deep learning will definitely be able to identify. That is the fundamental of, that is what our theory is, that if we are able to see through our eyes, you should be able to see or do deep learning on top of that. So if you are applying any kind of pre-processing, always do it on an image and look at yourself visually and see if this is helpful or not. See, if I changed my setting to mean plus standard deviation now, and I can clearly see the difference between the gradients. So here in the bottom left, I see a darker region, and I am able to see those lines very accurately, and now I am able to see it very accurately. If I change it to cumulative count, again it changes. If I change it to min max, you see min max is not very useful here. So if you are applying deep learning, it's better that you do the setting. Any pre-processing step you want to apply it on, say, take your image to QGIS, apply that filter or apply that raster pre-processing step, and look visually if it is going to work or not. I have on the top, I have few other settings as well, decrease gamma, increase gamma. So I can play around with these as well. I can increase the contrast, decrease the contrast, and whichever gives me best result for distinguishing two features, I take that setting and then apply on my deep learning algorithms or as a pre-processing step. So these are four key settings that you have to look at. One is contrast enhancement. On the left pane you see stretch to min max. What I do is stretch to min max is a good option, but say your deep learning model has outliers and you want to clip it, maybe you can load your image here and then bring that setting stretch to clip and max and then see, oh, is it working or not, is it working fine for me or not. Maybe there are some outliers that I don't want, and see here, if you see at this location, it has clipped that region and excluded that part itself because I have done stretch and clip to min max. Now if I just click stretch to min max, I still have this value. The reason is this region has very high elevation. Maybe it is a peak or a mountain nearby, and I don't want to exclude. I want to exclude that. I can change my settings and see if this is working fine for me. If I'm happy with it, I'll go ahead and apply the same setting on my pre-processing step for deep learning. So that is the initial step you take. Another thing that so we'll come back to these settings again when we do some kind of image processing, but our goal here was to identify the elevation difference between 2 points, and for that we use, if you come to view and click on elevation profile, view and elevation profile. I hope everyone has, it is there in the latest version. I'm not sure if it is there in 3.28, I'm not sure. It should be present in 3.34. Hope everyone has this toolbar. You come to view and then click on elevation profile. Now with this tool, it's a really useful tool. I'll tell you why these are used across multiple places. Now once you've selected this, you can you see an option called as add layers. Just click on that and select the digital elevation model layer. You click on the left pane and then click on add layer, then select the digital elevation model. Once you have done that, we go to the location that we want as our start point. Say I've selected GalaxEye space as my start point, and now I want to calculate the elevation difference between this and the road, the main road that is connecting. I want to know the elevation difference. The way I do it is, here you have an option called as capture curve. You click on that, and now there are two things you have to do. One is select the start point, which is I select this as my start point, and then draw a line through that road till the end point. So I click again and right click. I don't know if you're able to see that line I've drawn. So now you visually see that the elevation is decreasing. We are at an elevated region compared to the road connecting it. So now you know when it rains, there will be flooding on the downstream side and not here, because all the water that is coming here will go to the downstream. And if you want to identify specific region of the elevation, say when you just hover around, you also have this black dot also moving along with it. Maybe you can see that black dot is moving with me, and that tells me the exact elevation at that point. So say at GalaxEye the elevation is 19 meters. One second. Oh, not 19 meters. It's 898 meters. So that is the elevation we are currently at. This order tells you how you have drawn a 1 kilometer stretch of line, and you know both the x and y and also the z of this location. So as you move around, there's a black dot that is moving around with you, and it tells you what the elevation is at each point. So here you can see 880 is the elevation at the right, at the end of the road. So now you can again come back and do for entire Bangalore. Say I start here and then draw, like crossing the entire Bangalore. I've just drawn one line which crosses entire Bangalore. Now you know if you travel on this route, you'll have a lot of peaks and a lot of dips. Now what I want to do is, I want to select this stream and then see where it is ending. So I've drawn one line which passes from low elevation to high elevation, and now what is happening is the elevation, you've drawn a 25 kilometer line. Now elevation is constantly increasing. So here you can say that, just looking at the image it might be difficult to interpret, but with this tool now you know that the Bangalore west side, which is RR Nagar Vijayanagar, all these regions are low-lying areas compared to the central Bangalore, say Jayanagar or Basangudi or even North Bangalore. All these are at little higher elevated regions. So even if you see now, recently there has been a lot of rains and there has been a lot of flooding. So if you want to know, there is Whitefield and Vattur and all these regions have been flooded. These regions are low-lying areas. If you want to compare, maybe we can just draw a line here and then see. So these are like low-lying areas, and then you increase, the elevation has been increasing. So you say if you want to select a property or want to buy a property, now you know where to first look at. And then always buy not at very low-lying areas. Those have, with the proper flooding or drainage system, even that is not a problem, but this is one thing to keep in mind. So whenever drainage systems are planned, those are planned at low-lying areas so that water which accumulates, even the most of the lakes that you see in Bangalore will be at the low-lying areas and not higher elevated regions. This is one kind of proof checking that you do. Alright, so this is for the elevation that we have done. Now there is one important thing that I want to do, because at GalaxEye also we do a lot of fusion. I want to show you, so you might have seen images of Umbra, and now what we'll do is, keeping everything as is, so there's two files that I've added from SpaceNet Challenge. These files will be in your drive folder. I want to show the power of QGIS and why it is important to visualize your data first before doing any kind of analysis. So if you go to your folder, you'll have two files, SN6, one is optical image, one is SAR image. You don't have to worry about what these images are if you are not from this domain, but optical images are similar to your cameras, your normal cameras, and SAR images are these radar signals that we sense and then create an image out of it. It's not an image, but it's information that we gather. For every point there is a radar signal that you gather. So these two images, they have of the same location. One is an optical image and another is SAR image below that. I'll just close this pane, elevation pane, and we've completed that section. Now what we want to do is, we'll first look at this optical image. You see this is very high resolution image. You can see those tanks, and there is a canal or canal that is passing. I don't know which region it is. Let's check. Yeah, it's Rotterdam, so it's Netherlands. And you have these, there's a canal that is passing through the city, and beside that there are there's factories around it. So the satellite images have captured, there is one image captured from say Maxar, another image from say ISI or Capella. So these are satellite providers, but what we want to do now is, we want to blend these images together. Again, this is one power that I want to show, is how do you blend these together, or how do you fuse them together. Say highlight few features of optical and highlight few features of SAR. And if you want to do that, you can play around with QGIS in such a way that you have some kind of knowledge as to what deep learning model to use then. What we are going to do is, we are going to blend. So that is now the theme. What we are going to do is, we are going to blend these images. The first thing that we do is, when we select the optical image, it's better that you rename your layers. You can right click on the layer and then rename. Just right click and rename. Okay, so what we want to do here is we want to blend these two images together, and for that we come to layer panel, which is on the top left. Open the layer styling panel, and inside that you see a blending mode. So there's an option called as blending mode, and we'll play around with this blending mode and try to fuse or merge these images together so that it looks as one image. We click on this blending mode and click on multiply. So just with multiplication setting, you are now able to see the SAR image beneath it and also the optical image, but certain features are not highlighted currently. So if you want to highlight features, here on the screen it is not visible, maybe you should try it on yourself. Try to change the setting, blending mode to multiply, and then change the contrast. Now just change the contrast. Now you will be able to clearly differentiate between land and the surface, and also these features from SAR are being highlighted. So if you were to just look at the SAR image, if I turn off my optical image, and if you were to just look at SAR image, here you are hardly able to differentiate between water and land. But if you were to club these together, optical and SAR, now what you are able to do is you are able to differentiate water and the land, and also have the optical the SAR features highlighted. So this is one of the settings that this is just tip of the iceberg that we are exploring here, is blending modes. But what you could also do is, I've tried to, so it takes a lot of trial and error. I've done another blending mode, which is subtraction. What these blending modes are doing is, multiply is basically you're multiplying two images. Subtraction is you're subtracting two images. You try to subtract these two, and then also the beneath layer, the SAR layer also, you try to subtract, and then increase the contrast of the first and increase the brightness of the second. So all these with these settings, now we can clearly see the shadows. In SAR image alone we were not able to see the shadows, but now we are able to see the shadows if you try to change both layers as subtract and then change the brightness or saturation. I mean, the point of doing this exercise is, before you apply any deep learning algorithm, you have to visualize your data and play around with the settings yourself beforehand. Once you are comfortable or you think okay, these settings are going to work out, then you apply those same settings and then on the deep learning model. Now I know that if I subtract two images and put that as a loss function in my deep learning model, I'll be able to get the shadows. Or if I multiply both images, I'll be able to differentiate between land and water. So QGIS is an excellent tool for doing that. It allows you to manipulate images and also play around with settings of multiple images together. Okay, so now we'll move on to the last step. Again, if there is, I know I'm rushing through a lot of different topics here, but I want to highlight QGIS cannot be learnt in a month or even 2 months time. It takes, even for pro users, anyone who is still developing QGIS, there are multiple new features each and every day. So what I want you guys to take home from here is there are multiple different things that can be done with QGIS. You can do, as I said, you can visualize data, you can analyze data, and you can also do some processing on images. And on top of it, because it is geospatial data, you actually look through your eyes and then do some kind of manipulation with the data itself. Now one kind of, you see a lot of in news reports there are a lot of maps that gets published. Now at this step, after this we'll go into deep learning or digitizing aspect, but I want to also explore this avenue is journalists use QGIS a lot, because for them they don't want to pay ArcGIS, it's very expensive. QGIS does the job really well. And why do they use QGIS? Because they want to create good maps, good quality base maps, good quality. Say for India map, if you want to put this in a newspaper, how do you think these guys or journalists do this? What they do is, first at the initial step they do all the processing in QGIS and they take that to say Illustrator or similar kind of softwares, and then they tweak for the styling aspect. The initial part of it is done in QGIS. We'll do some similar small activity here, is we'll style layer and we'll label the layers. So here what we'll do is, say for the India, the boundaries, we want to style the layer or make the borders thicker and have India as the label on top of it. So what we'll do is, we'll select this polygon and again go back to the layer styling panel. You go back to the layer styling panel, and then the first thing that you could do is change colors, obviously. So there are default colors here in bottom. You can click on any and the color changes. You can select gradients. You can also do hashed lines, so that you also are able to see beneath the layer itself as to what the underlying area is. Or you can also do just borders. So you can also do borders, and to go a step further you can also, so these are like multiple options that you can do. I'm not going to go into all of this. What we'll do is, we'll select the green color, say we select the green color, and once we do that, there are multiple settings that you can change. Inside fill, there's a simple fill. Now you come here and then change the color as well of this fill. Oh, sorry, no brush. So there are main two things. One is the fill, which is inside the polygon itself, what you want to color that region, and the borders. Say I want to color the borders differently. So I select green, say red, and then I increase the stroke width. So I can do all kind of funny stuff here. Is now I've increased the border, and now I don't want my inner region, which is filled, to have solid color, but I want to have some kind of, so I can change the density, and again the list goes on and on. So you can do multiple kind of things with this. You can also say if you want to color each polygon differently. So this one is one polygon, but these regions I want to color differently, and these regions I want to color differently. You can do that as well. Instead of having a single color throughout, you can click on top and then click on categorized. So once you click on categorize, you can click on the ID or something which is unique, for all the polygons and then click on classify. So I think ID is the same for all. I'll click on FID so that you have different colors. Now I'll decrease the stroke width, and now you will be able to see different colors for different regions. So what we have done is, instead of having a single color which was initially single symbol, now we have changed that to categorized, and then changed this change the color of all the symbols. Okay, say once you are happy with the color, now you want to print this out and say stick it on your home wall. You can also do that. You can take a printout by just clicking Ctrl P, as you do with all other things. You can take India border, you can click on Ctrl P, and this will bring a print layout. So in this print layout, you can add the item as the map. So again, if I were to explain it again, you just click Ctrl P. Once you do that, you can click on add item and then add map. And there are multiple settings here which will not go deep into, but suppose you are satisfied with this, you can come out to layout and then export as PDF. Now this will export this layer. I just click yes for all the settings. Once it is done, I have a PDF ready, which I can open it, and so here you see I have my India borders with the base map. Behind it. So these are the kind of things you can do. Again, if someone is stuck here, you just Ctrl P and then load that map onto the screen. Alright, so we have explored multiple things. We have explored how do you style, how do you query rasters, how do you blend rasters, how do you calculate area for vectors, and now we'll come to digitizing, as in how do you make a new layer. If you want to do, what we have done is everything was given to you already, but if you want to make another new layer, say for any region, say you want to draw your home boundary from the top, from satellite images you can see your boundary, so maybe you can draw those shapes. And if you want to do that, say if you want to identify all the water bodies in Karnataka and you want to train a deep learning model for that, the first step would be to create layers or create data set for that. Now to create data set, now these water bodies keep changing each time. Say KRS dam recently dried up because the summer was very harsh and there was no rains in summer. Now the water bodies have shrunk, and you want to quantify as to what is the trend of when does the water is at maximum capacity and when is it at minimum capacity. And for that you have, say you are tasked with doing a deep learning model, you are not doing some other algorithms, you are tasked with doing deep learning model. What you do first is you create a data set with the satellite image as base map and you label the region where you see water. Once you do that, then you pass or create some pre-processing steps that we have recently studied, then pass it to the neural network. But the first step itself is quite difficult. I've seen multiple people face challenge for creating this labeled data set. There are multiple tools in computer vision for labeling, but none of them comes or match to QGIS. Reason being the ease of use. First, if you get familiar with QGIS, there's nothing like it. This is the best tool for doing any kind of analysis or even doing labeling. Now we'll look into that. Our task now is, as I mentioned, is to identify all water bodies in Karnataka. Maybe you can do some kind of other steps. Maybe you can take from KSR SAC's website. You can see what is a trend of water bodies. They might be doing some kind of analysis. If you want to do similar kind of analysis for yourself, the first step is creating a data set and identifying water bodies. Now what we'll do is, I've already shared with you, you can close off all the layers, keep the OpenStreetMap layer as is, and open the images or turn on the images pane. Once you turn on the images pane, click on any of the image and right click on it to zoom to that layer. Now these images, so these are satellite images. A little bit about these images, for someone who don't know, these images are from a satellite called as Sentinel-2, and these are at 10 meter resolution. So if you zoom in very high, every pixel here will correspond to 10 meter. And this is free of cost. Anybody can use it and without any licensing issue, you can use it for free. Just make sure to attribute it. So once you've done that, I have downloaded these images, but you might find it very hard to download images. The first biggest challenge that I see is people, how do I download these images? There are multiple different resources. There's one not single source of truth, or like even if multiple websites are available, you have change in values in the reflectance value or the values within the image itself. Now the official website is the Copernicus website, and that is what we'll look at. We'll look at how to download images, not download images in this case, but what we'll look at is how do you label images. For that we want base map as our reference. Now we are going to explore plugins now. Now plugins are basically an additional component or third party softwares that are inbuilt, not softwares, are plugins or just a piece of code that you can insert into your core software area. So what we are going to do is, we want, similar to the base map that we have, say Google Earth, these base map don't update quite frequently, once in 6 months or once in 10 months. Maybe if you are lucky, once in a month, or else I've seen a lot of places have old base maps, say 2 years ago. So these maps are very old. To have the latest imagery available, you want to have the satellite imagery which is captured every 5 days or every single day. Multiple satellites are captured every single day. Now to load those as base maps, we'll explore the plugins section and click on manage and install plugin. Again, this is last section. After this we'll end the session. But if you go to plugin and then search for Sentinel Hub, and click on install plugin. So once you have this installed, you'll have this icon on the top pane, Sentinel Hub. If you're not able to find that plugin, you should just right click, and here you must be able to find it, but the logo is of the Sentinel Hub. You should be, once you have installed it, you should be able to see that plugin, and click on that plugin. And you see a dialog box pop up. Now, for those who are first time users, I mean all of you might, I assume, is first time users, you have to click OAuth client on the bottom. Click on OAuth client. So once you have done that, oh sorry, my bad. What you have to do is go to a website called as Data Space Copernicus. At the end of this exercise, you will be able to load the base map with the latest satellite imagery. We go to Data Space Copernicus, and I ask every one of you to create an account there. Click on register. Data Space Copernicus, please click on create an account. On the right, you will see a register option. Please click on that, and not the left pane, and not the login section. Click on the register option. And this will give you a form. So you have to fill this form. So the steps, if I were to repeat, click on go to Data Space Copernicus, create an account on that page. You can click on anything. Yeah, that also you can. So if you have some confusion on which user you are or which thematic category, you can select anything. It is for their use. Nothing to do about create an account. Okay, so you've signed up, and then now once you've signed up, you can log into browser data space. Again, log into the Data Space Copernicus. You can go log in Data Space Copernicus. So you'll have a Copernicus browser option. Click on that. I'll wait for everyone to finish logging in and registering for yourself. go to browser data space Copernicus. So here what you see is the latest satellite imagery. Once you go to, you don't have to log in to access the latest satellite imagery, but if you were to load in QGIS or download the imagery, then having access to base map is required, or logging access is required. So hope everyone is on the browser. If you are logged in on the browser, you will see on the top pane under your user, you will see an SH dashboard, which is Sentinel Hub dashboard. You have to click on that. So in the browser, there's a dashboard. You have to click on the dashboard, and then in your settings, you have to create an OAuth client. So once you're in, see, the steps are from your browser, you click on SH dashboard, and on the top left, top right, there's a settings pane. You click on settings pane and click on OAuth clients. You have to create a new OAuth client. So I'll do it in a new page. You can write the client name. Again, if I were to show you SH dashboard, you click on SH dashboard, and this brings you to the dashboard section. On the top right, you have to click on settings, click on OAuth clients, create a new OAuth client. Give any client name, you can give your name and give the credentials. Sorry, everything still remains the same. Just say as never expire and say you understand the risk, and client will be used by single party only. Sorry. So once you enter all the fields in this, say Aman Bagrecha, then client credentials, and never expire, then you can click on create. This will give a client ID and client secret. So copy both of them and save it somewhere, say in a database or in your text editor, wherever you want to, because this will be used in entering it here in the QGIS. What we want to do is load that same base map on QGIS, and for this you have to do all these process. You copy, because once you close this you are not able to access again the client secret, so just copy it once and then paste it in client ID and client secret. You can paste it here. So I'll delete it because I'm streaming and I can't trust anyone. Just delete it. But I already have one OAuth clients. So what you have to do is just click on OAuth client. Once you get the credentials, enter it here. Enter the credentials in client ID and client secret, and then just click on login. But make sure your service URL is sh dataspace Copernicus EU, and you click on login. Once you click on login, there will be an option called as logged in. You're already logged in. Now because time is running out, what I'll do is I'll show you guys the setting, and then maybe you guys can do the entire process later if you wish to. But what we have to do is, once you have the OAuth, you have to go to the configuration utility, and for your configuration, suppose you have given configuration as XYZ. Within that configuration, you need to, suppose I select a new configuration. I give a new configuration as XYZ, and then you have to select from the configuration based, you have to select as Sentinel-2, select full WMS template. Click on full WMS template and click on configuration. Once you do this, you'll have all the layers here, and that is all you have to do. And come here again and click login. Logged in successful. So your configuration will be visible here. So because I had created a QGIS config already, I have additional XYZ configuration. And from these configuration, now I can select a variety of bands that I want to display on the screen. Say I want to just display say false color urban or false color vegetation. Let's select this, and then I select one specific date for this region. So the extent that you're seeing here, for this region the entire image will be displayed. I click on 20th and I say use exact date. I want the image for 20th. I want my cloud cover to be less than 20%. So when you decrease it to less than 17%, it says that I don't have any images available without cloud cover percentage. So maybe what is happening is August 20th it was quite cloudy, which is like 4 days ago, and which can be proved if you click on create. It will add another layer and you will be able to see a cloudy image visible to you. So just 4 days ago, this is the image 4 days ago, and this entire region, the Bangalore region, was covered with clouds. You are seeing only a part of tile because that is how satellite was passing through. And if you were to select some other date, say 13th, and then click on create, maybe you'll have a different so you have another image which is on the 13th of August, and now you can see the satellite image passing over Bangalore region. So it is quite cloudy as you might expect in August, and if you zoom in you can clearly see the clouds. It will take a little while to load, so you can clearly see the clouds and also the water bodies. All the houses here are also quite visible. These are, I think, farmlands. These are also quite visible. So what you've understood from this is, if you want to do labeling, the first step is to load satellite images and download it. I had done all the hard work and downloaded those satellite images, so you don't have to. But now you know how to load an updated or just load the base map of satellite imagery within QGIS itself. Alright, so we'll close out the Sentinel Hub API and we'll come to the final step of creating labels for satellite imagery. So there are two things you have to do. First, download images. Whenever you're doing a deep learning project, first download the images. Say I've downloaded 3 images in this case, but for deep learning you have multiple timestamp. Say take one from January, one from June, say one from February, and for every different date select a different region. Once you select different regions, you have that diversity that you need for deep learning models. So here you can see on the left pane I have different dates from different timestamps for different regions. Now this is for KRS dam that I have downloaded the images for, because I want to identify how the dam, the water extent is changing. Now for training the model, I have the images now, I don't have the labels. So to create labels, I use QGIS again. For that, we'll create a new vector layer, and once you create a new vector layer, we can start drawing our polygons. So here you see new temporary scratch layer on the top, which creates a temporary layer where you can start drawing or start mapping. And now we click on geometry type as polygons. I want to draw polygons, and keeping everything as is, I click on OK. Now my new layer is created. Once my new layer is created, I can click on this tool called as add polygon feature, and then I can start drawing. So by default you'll have digitize with segment. So what the feature that you have is, you just click here and then start drawing. Wherever you see water, you just start. So I'm just drawing roughly, but you know what to do in this case. If you were to create good labels for your deep learning model, so you have to go ahead and then, so I close and right click and I close it. So a feature is created. I'm not doing it exactly, but what ideally you would do is map the entire satellite imagery. Wherever there is water, you would map that with a polygon. So, and you cover the entire region with polygon. Do not miss any labels. Wherever you see water, just map that out so that you know, okay, this area also has water. Now similarly, you can also say I have another layer, let's also do it again, and I'll then tell you the pain point and we'll try to solve it. You can click on save. On the top there is an edit option. Once you click on edit, you are able to edit the layers or add new features to it. Once you have drawn the polygon and right click it, you can save the layer and then close the editing option. So now you have two polygons, say for this satellite imagery. Similarly you do for multiple other satellite imagery. Now the problem that you saw here was happening is I did so many multiple clicks. Now if the water bodies is has such curvatures, it's very hard to manually go there and draw it, as in click every time, do a click for every region. So what ideally you should do is, QGIS is a very nice feature in editing. I mean it has multiple different features. We'll explore one. When you click on the drop down, there is a called as stream digitizing. What it does is, say you want to start digitizing on this polygon, you just click one point and then just move your cursor. You don't even have to click. So you just move around and then draw the boundary. Again, you have to be very careful when you're doing this, say, and I right click. So my boundary is created. So now what I've done is, this is just one tool that I've demonstrated. Suppose your polygons or your lakes are circle in shape. You can also click on digitize shape, and here you'll have option of, say if you want to have circular or circles from 2 points. So if I want circle from 1 point, say circle from 2 points, I click on one region and then draw a circle. I can also draw a circle if, say, some feature of circle shape. I can also draw rectangles, or I can also draw arcs if something that you would like to. So even these things are available. There are also ellipse that you can draw. So there are various features which helps you in digitizing or drawing labels for your satellite imagery. Once you are like okay with all these labels, you can click on save, and then it ends your labeling process. Now once you've labeled your image, say this is the labeling process that we have done. Once you labeled your image, this is still a vector. You have to convert it to a raster. The last final step is to convert your labels to raster, and QGIS has that feature as well. Here we'll look at a feature called as rasterize. The way we do it is, again in the search pane, you click A space and rasterize. This will load all your. So this is one of the tools that QGIS provides. What you can do is you can now convert your vector to raster. I'll just click one. All these options, I'll explain it a bit. So 2024-03-11. I set the output extent as 0311 and then click run. Oh, sorry. Output raster. Georeference units. Oh, pixels 10 by 10. Click on run. See. Input raster size. Just a minute, guys. It is only creating. Any which way. So I think you have to change the. Yeah, I have to change. Anyway, I mean, it is little complicated here because you have to change your projections to the projection of this layer, but ultimately what you would do is once you have labeled your raster, you convert it to once you have labeled your satellite imagery, you convert that to a raster, and now you have pairs of raster and labels that you can feed it to the model. So if I show an example, yeah, it is different. Anyway, so I'll show you Okay, anyway, so once you have this, you can now click on Control S and that will save the project. And so we have come to end of this workshop. So few things which I wish I could have done is, after this, I mean, if there was more time, we could have converted or done reprojection and then converted your vectors to rasters. That is one step that you have to do. If I were to show you an example as to how these images would look like, never mind, I can't show it on live stream. I'll show it after it ends. But okay, so this ends our QGIS workshop. I would highly recommend. There are a lot of things that we have skipped, but everything is present on this slides. So you will see, if you want to explore themes, where you have two panes of base map layer. So on the left also you see base map, on the right also you see base map. You can now change what you want to display on the left pane and on the right pane. That is one thing that we did not cover. Another thing that we did not cover is spatial analysis. If you want to do, say, buffer, clip, join, so all these, or table joins, if you want to do joins here, you can also do that. And one thing also is coordinate reference system. So these are the things that we did not cover, but